Right now you have a do now at the top that gives you a function, and so I would suggest using Desmos to type in this function and determine these attributes. Maybe pause here and see if you can do that. So I'm going to graph it. I'm going to go ahead and go through it, but this is do nows are a good way to make sure that you know what you're doing and you're on track to make sure that you are good. Okay. So if I look, it never stops going left and it never stops going right. It keeps going forever. And it also goes down and it goes up. There's no stopping spots. So because of that, we went over this on 3.1, that the domain is all real numbers. And the range is also all real numbers. Okay? The x-intercept is going to be where it crosses the x-axis, and the y-intercept is where it crosses the y-axis. So we're going to write those two numbers there. Okay. My slope I can actually get from the equation because it's in the m spot. My slope is 1/4. And since my slope is positive, it is increasing. Alright, so let's look at this graph right here. It says you can translate. Today we are going to describe orally and in writing the effects that different transformations have on the graphs of the linear parent function. So when I look at this, you can translate the graph of f of x down 3 units by moving each point 3 units down. Okay, then we're going to label the transformed graph as m of x. So to translate it on f of x, we subtract 3 units to the output value or y value. The input value remains unchanged. So these x's are going to stay the same. But then my y's are going to shift down 3 units. So I will subtract 3 here, which would give me -5. Subtract 3, give me -4, -3, 2, -1. And then we are going to graph that. And so this graph is the same. What I did was I took my f of x values and all I did was subtract 3. So the y-intercept shifted down 3. And the x-intercept shifted right. Alright, let's do the same thing, but now we're going to double the vertical distance from the x-axis for each point. We're going to label this graph n of x. To dilate the point, multiply the output value or y value by a factor of 2. So here we're going to put these, because these remain unchanged. And so we are taking f of x, and what we're going to do is we're going to multiply everything by 2. This would be -4. This times 2 would be -2, still 0, 2, and then 4. How has this change affected the y-intercept or the x-intercept? They actually are the same. How would this fact, because the x-intercept and y-intercept are still 0, how would this change if the factor was -2? So instead of increasing, my graph would be decreasing. Okay, and if you look at how we wrote these, what we can do is we can type our parent function into Desmos. And then I'm going to type the one that that I did. And those graphs should match. So this first one certainly does match. And I changed this to 10, and I changed it to 2. So then let's look again. If it was -2, my graph would just be reflected, and instead of increasing, it would be decreasing. Okay? Alright, so now we're on the back page of this, and this is just a little bit of like stuff that we're going to talk about. So the linear parent function is always this f of x equals x. So typically when we change the parent function, this is called like the identity function, we can change the slope and we can change the y-intercept. However, instead of, like we have y equals, but in function, for fancy y notation, we have these variables a, h, and k. Okay? So this a value is the vertical stretch or compression, and also it will reflect it, making it go from increasing to now decreasing. Okay. H is going to be a shift left to right, so horizontal shift. Left or right. And K is the vertical shift, either up or down. Okay, so these are factors that can be added to the equation to make it change. So let's look at how this works down here. So you describe the graph of f and g. F and h are related and given when I have the linear parent function. So the first thing that we're going to do is we're going to go to Desmos and we're going to graph that linear parent function. We already have it there. Okay, and then we're going to graph g of x, which is negative f x plus 2. Okay, and I'm actually going to take away this negative right now and try to do it one at a time. So if I think about the way that this shifted to the left too, because it's inside the parentheses. And it also changed from positive to negative. Do you all see how that changes there? So the things that are happening, if I want to describe it, this is going to shift left. And it's going to be reflected over the x-axis. Alright, now let's do h. Instead of a negative, this has a 3. Okay, and again, I want to do it like one at a time. So I'm going to delete this 3. So that 4 makes it go up 4 because it's outside. It's where the k is. And then this changes it to being steeper by a factor of 3. Okay. So this right here is the vertical stretch. It's stretching, it's getting steeper. This is making it go up 4. So we say vertical, so vertical stretch by a factor of 3. And in parentheses, I'm going to write steeper. And then it is a vertical shift up 4. Okay, so let's look at this graph right here. This has the parent function on the left. This is f of x equals x. And on the right, we have this function c. Okay, so if I look at where the y-intercept went, it went from 0, 0 all the way down to 1, 2, 3, 4, 5, 6. So it shifted 6 units down. the x-intercept horizontally shifted 1, 2, 3, 4, 5 to the right. So if I think about my slope, I went up 6 and I go over 5. That's not the same as going up and over the same amount. So the parent function has a slope of 1, and on this one my slope equals 6 over 5. So 6 over 5 is actually steeper than that, and that's the factor that's doing it, pi. Okay, so y'all see if you can figure out this last one. Again, these are guided practice problems that are on your MyOpenMath assignment or in Canvas, so go find your assignment in Canvas. Thank you so much. Hope this helps.